In this presentation, we will unveil the latest version of ATiles version 3.0. This comprehensive video will provide a detailed exploration of all the plugin's parameters. To navigate to specific sections of interest, please refer to the video description for chapter markers. Let's get started. Once you have successfully installed our all-in-one application, navigate to the 3ds Max App Store menu, locate Office Studio Tools, and select Setup to check for updates. If there are new updates for our suite of tools, you can download them directly from this window. Then proceed to the ATiles options, select the most recent version 3 from the drop-down menu, and press the Load button to activate your selection. With the latest version in place, you are now ready to create your first ATiles object. Begin by accessing the Create panel, then select Office Studio Tools from the top drop-down menu, and then click on the ATiles button. Simply click and drag in the viewport to start shaping your first object. The second point not only determines the size along the x-axis, but also sets the object's orientation. The third point specifies the size along the y-axis. These values can be further customized manually in the parameters rollout. Here you can also set the number of tiles along both the x and y axes. Moreover, you have the useful feature to make the tile count fit perfectly within certain dimensions. The spacing between tiles is just as easy to customize. Simply alter the offset values for the x and y axes. If you want the plugin to calculate the tiles count based on the object size and the chosen offset set count x and count y to 0, by default the offset is measured as a percentage of the tile size. You can also set it as absolute value, defining the distance between tiles and system units. For instance, you can set the offset x to 2 cm and offset y to 3 cm between current tiles. Additionally, adjust the offset z to offset each row in the z direction to create objects such as step stairs or similar. The next offset R parameter shifts every second row by a specific percentage. For example, at 50%, this could be used to create patterns of brick walls or similar. Moving on, let's explore the angle options for your ATiles object. The tilt angle allows you to rotate tiles by a specified angle, making it exceptionally useful when modeling roof tiles that require specific angling. For example, a classic 30-degree tilt could be the perfect match for these roof tiles. The start angle defines the angle from the starting point with a default value of 90 degrees, and you have the flexibility to input values ranging from 15 to 175 degrees. End angle and top angle parameters offer similar flexibility, allowing you to adjust these angles just as easily to match specific requirements. Activating the base angle feature provides you an additional layer of control over the base edge of your ATiles object. Now let's reset our angles and explore the features that enable you to choose different tiles. To illustrate this, let's unhide some basic geometry. Within the Modify panel, it's a simple task to add new tiles to your object. Simply click that Add New Tile button and select any geometry from the current scene. Take a look at how our simple boxes can morph into cones. The same can be done with this cylinder and pyramid. Moreover, you can set the first row of your object to feature a specific shade like a cylinder. With the new Edit Tile List dialog that comes with this version of ATiles, managing these adjustments has never been easier. Here you'll notice your main tile choice, in our case a pyramid, and the first row tiles, which here are cylinders. You can also choose to use a cylinder for the last row of tile. For the first column, maybe a cone suits your vision, and likewise you can assign a cone for the last column, all within the same dialog. For our example, let's slightly increase the sizes along the X and Y to get a clearer preview of the tile variations. In this version of ATiles, we can also specify different geometry for the corners of our object. In the Edit Tile List dialog, we can add new tiles by picking this sphere and this teapot. Please note that when you add a new tile in this manner, the geometry is added to the object, but is not automatically set as the current tile. Now with these two new objects in place, we can set the bottom left and right corners as spheres, and the top left and right corners as teapots. This configuration allows us to employ 9 distinct positions for different tile shapes within the object. But that's not all. We can also define a viewport tile. For instance, if we choose a plane, we can optimize this viewport performance by applying simpler geometry for the viewport, while the original geometry is displayed when rendering an image. To manage these viewport tiles, simply click the center button in the parameter window. When this button turns blue, click it again to switch to the viewport tile and set it to default if you want to preview all the rendered tiles in the viewport. Then to go back to your main tile, click the center button once more. Continuing our exploration of the Edit Tile List dialog, you'll find that managing your tile selection is now more convenient with options to select multiple tiles and delete them if necessary. Renaming tiles couldn't be simpler, providing clear, organized labeling for your projects. Moreover, updating the geometry of your tiles is done effortlessly within the same dialog. As an example, if we change the cone's number of segments to 9 and hit the Update button, the geometry within our ATiles object updates instantly to reflect the changes. Should you want to replace any tile with a different geometry in this easy tool, you can swap on our example cone for a pyramid and then switch it back just as quickly. This latest iteration of ATiles also introduces new group options. Select multiple tiles you wish to group together and click the Add New Group button. From there you can give your new group a name that suits your collection. This added feature allows for the randomized distribution of the group's tiles throughout your object. If the group is selected as the main tile, you can instantly see the effect in the viewport. You can also set the tile seed, generating different random results for each seed. If you'd like to regulate the frequency of certain tiles, the percentage setting for each tile in the group is exactly what you need by setting as one face to 10% and as two faces to 10%. You can ensure that the majority of your main tiles will be boxes. You can also add objects to your group by selecting them from the list on the left and clicking the Include button. As a result, a sphere has been added to our group. To remove this sphere from the group, simply click the Exclude button. Alternatively, you can double-click the tile's name to include or exclude it from your group. Apart from random selection, you have the choice to cycle through your tiles, either in a forward loop, a backward loop, or alternating between the two. For our example, let's revert to the random loop option. Let's explore Advanced Parameters Rollout. Within the Optimized group, we find options that refine how we interact with the plugin. For most scenarios, the default settings work well and are advisable to stick with. Nonetheless, when dealing with large objects like the one we have here, you may run into an instance where the preview displays just 9 tiles. This indicates that the maximum tiles count set in the Optimized section has been reached, and the object won't be fully generated. To address this limitation, you can increase the max count value, ensuring your object is constructed in its entirety. Additionally, when using high polygon geometry like this cone as your main tile, you might notice that the initial preview shows the detailed cone, but later it converts to a two faces object to streamline the viewport performance. This transition is defined in the Create parameter, where you specify how many faces you want to see in the preview before the plugin switches to the optimized shade selected below. For instance, doubling this value results in twice the amount of geometry being displayed before switching to a two faces mesh. Next, within the scale parameters, you have the ability to internally scale your tiles. When you lock the scale of the element and the offset, both use the same value. Furthermore, you can also internally scale the local X, Y, and Z axes of the object individually, or lock them and scale them uniformly. In the Align parameters, you can precisely orient your tiles relative to the object. For example, you can rotate your tiles by 90 degrees in the X-axis, and the Y-axis by 45 degrees, and then the Z-axis by 45 degrees. It's also possible to offset the tiles to the origin and the X, Y, and Z dimensions. Additionally, you can align the tiles by mirroring them in different planes. To revert all these changes, press the Reset button, and you will reset all the advanced parameters. The UV mapping feature is straightforward. You can enable it and select the desired channel and mapping type. Now let's turn our attention to the Couples Advanced Parameters, a feature introduced in the latest version 3 of ATiles. This functionality gives you the power to seal the ends of your object, ensuring a finished look. If we reset all parameters to defaults by holding Shift and pressing the Reset button, you'll see that the edges of this object are immediately covered with polygons upon creation. In previous versions, applying a couple modifier was necessary, but it didn't always provide precise results, especially in corners. Now this functionality is integrated by default. The Use Mesh option is selected for fast interaction, but the resulting objects may not have the optimal topology. This method adds additional vertices along the edges, which may not be ideal for further editing. For this reason, we've introduced another option, Use Poly. This option is slower and is still in beta, so it may pose occasional compatibility issues with 3ds Max. We recommend using it only when absolutely necessary. When selected, you'll notice that the update process is slower, but the generated mesh is clean without the extra vertices produced by the first method. In the cap hole section, you have a few additional options. To demonstrate, let's apply a simple material to the object. Here you can alter the material ID of the new geometry, adjust the smoothing group if needed, and modify the napping to your preferences. Now moving forward to the Advanced Tools parameters, let's begin with the first button that opens the ATiles ToolBox. Here we can access all object parameters, but the key distinction is that we can simultaneously manipulate multiple objects rather than just one or instances of the same object. For example, if we create a new node and select both of these objects in this dialog, we can specify the x-coordinate for both of them even though they are not instances of each other. In the Advanced Tools Rollout, we also find region options, where we can define a region with a closed spline that will interact with your ATiles object. For instance, we can pick the circle as a region, and we can subtract it, intersect it, or ignore it. Equally useful are the volume options, which function similarly to the region options, but instead use a closed 3D geometry like a box to define how it interacts with your ATiles object. These features can be especially useful for creating openings. Moving on, we have the path constraint. If we create an editable spline path and add it to the object, you'll notice that the ATiles object aligns itself to the path. This is particularly effective for crafting curved walls or similar structures. What's new in this version is the path angle parameter, offering the ability to rotate your entire object around the path by a specific angle. The surface constraint works in a related manner to the path constraint, but instead of a spline, we utilize a plane or any other geometry. For example, if this ATiles object is positioned above the plane, and then the plane is picked as surface constraint, then tiles will align themselves to the surface and it's normal. Or you can opt to ignore the surface entirely. One significant upgrade in this version of the plugin is the option to extend the surface effect. If we lack sufficient information about our geometry, we can still generate the surface intersection based on the projection of the selected surface. For instance, by updating the modified plane, we notice that some tiles are not aligned to the surface due to the absence of geometry beneath them. Choosing the Delete Outside the Surface option removes these tiles. However, by extending the surface with the new parameter, we gradually see our geometry be revealed and positioned correctly. The last set of parameters in this rollout control the alignment of the tiles when path or surface is selected. When Align the Custom Point is checked, we can align our individual tiles, position them precisely. For example, by setting the values to 50 for X and Y and 0 for Z, the alignment point will be at the bottom center of each tile. Should you adjust Z to 50, the alignment shifts to the exact center of the tiles. Introducing a negative value for Z allows us to offset the alignment by 50%, elevating all our tiles above the surface or the path. Now let's advance to the variations rollout parameters. In the first group of options, we gain the ability to introduce random material IDs to individual tiles. This feature can be selectively applied to specific IDs of the tile's geometry. Moreover, you can specify the range of IDs for the random function, allowing for precise control. For instance, selecting a range from ID 1 to 5 will yield a series of blue tiles, whereas choosing IDs 6 to 10 will mix reds and yellows into your palette. Setting the range from 1 to 10 will produce a blend of blue, yellow, and red tiles. The random transform section lets you introduce an element of randomness to your tile scale, rotation, and position. With the transform center setting, you can pinpoint the reference position for these random transformations. For instance, turning on random scale in the Z direction and moving the Z transformation center to 0 means your tiles will grow from the base upward. You can also apply non-uniform scaling such as 1.5 in the X and Y axes. It's worth noting that when you modify the second scaling value, the first linked value adjusts to match, simplifying your workflow. And if you want the first scale factor to be 1, it's straightforward to reset it back with a quick edit. Let's explore the rotate parameters. This function permits you to vary the rotation of each tile in the X, Y, and Z axis, anywhere from small adjustments like 60 degrees to a full 180 degree. If you modify the rotation of the tiles in the x-axis by 20 degrees for the first value, the second value will not change automatically. With the move parameters, you'll also apply random translations to your tiles in the x, y, and z directions. These variations can be implemented at a sub-object level. To demonstrate this, let's switch our main tiles to a teapot. Enabling the Apply on Sub-Object Level option for the material ID reveals random materials applied to the individual parts of the teapot. It's worth noting that you can exclude any material ID of the geometry. Additionally, sub-object level transformations are also possible, illustrating that you can not only move, scale, and rotate the entire tile, but also apply these transformations to its sub-objects. Lastly, within the About section for the ATiles object, you can access information about the plugin version you are using and find a link to the product page. Here you can also see specific data about the selected object, the number of tiles used to build the mesh, the face count, and the duration it took for 3ds Max to generate the object. If you're utilizing a viewport face, you'll find information regarding the time it took to build the viewport faces. In this example, we can also turn on Apply Transformations to the Viewport Tiles option to see the full preview. The ATiles ToolBox, as mentioned earlier, is a powerful tool that allows you to modify all the parameters available on the Modify panel. What sets it apart is its ability to make these modifications across multiple objects. For example, if we create a new ATiles object and select this and other objects simultaneously when opening the Modify panel, we won't be able to access any parameters. However, within the ATiles toolbox, these parameters can be easily altered for all selected ATiles objects. Toggling the Apply on sub-object level lets you instantly see the results in the viewport, ensuring consistency. But the benefits of the toolbox don't stop there. It also introduces specialized methods for creating and selecting ATiles objects that can significantly speed up your workflow. In the toolboxes Create and Select Rollout. The first button initiates an ATiles object creation, just as you would from the 3ds Max Create panel. The second button lets you create an ATiles object from a roof plane. To illustrate, let's create a pyramid and reset all the parameters of the current object by holding Shift and pressing the Reset button. Then, in the Variations rollout, we can apply random material IDs and select one of the default roof tiles as the main tile for the object. With the From Roof Planes button engaged, you can now select polygons and generate roof tiles for them. The Select Last Created button enables you to select all newly created ATiles objects for further customizations. Once this is done, you can fine-tune the random material ID range to only select warm colors between 6 to 10 for current roof tiles. Expanding on the creation capabilities with the Create in Geometry button, you can generate similar objects to the previous one, but with different alignment. With this button, you not only select a polygon in your scene, but also specify a baseline and a starting point for your new ATiles object. For instance, by selecting a point closest to a specific edge, your roof tiles will use that edge as baseline, aligning differently from the horizontal orientation seen before. The placement of new objects starts from the vertex closest to your selection point. Selecting a different point in the polygon could lead to the object extending from the opposite direction. Additionally, you can create ATiles objects from any editable spline objects in your scene. By pressing the Create from Spline button and selecting a spline, you can use that spline as a path with the size Y of the new object matching the spline's length. Enabling the vertical plane option will produce curved wall with shape of the path. In the Advanced Tools Rollout, you can check Align to Custom Plane and set this point to be at the bottom center of your object, or improve the alignment of the tiles with the selected path. The Recreate mode is another handy feature which gives you the opportunity to overhaul existing ATiles in your scene. After selecting an ATiles object, select one of the previously mentioned creation methods to rebuild it. You can repeat this process as many times as needed. To select all visible ATiles objects that have similar parameters, select any ATiles object and press the Select Similar button. To demonstrate the next new creation options, let's move these objects aside. In version 3.0 of ATiles now, you can automatically create objects not just one by one from individual polygons. In the new version, you can also generate all necessary objects with a single click directly from a single mesh with multiple polygons. To demonstrate that, let's switch to the straight line. First, press the From Roof Mesh button, and then select the desired geometry. As you can see, all the edges are created effortlessly. To refine the result, you can use the Select Last Created function to delete any unnecessary geometry. Further optimization can be achieved by cleaning up the geometry of the pyramid, such as deleting the bottom polygons. By selecting an object with the desired roof tiles, and by pressing the From Roof Mesh button. Again, we can create all of the required roof tiles for this example in one go. This functionality is unlimited to basic objects like this pyramid. You can apply it to more complex ones as well. For instance, you can create a sphere, delete some of the polygons from the bottom, and scale it up for better visibility in the viewport. Then by pressing the From Roof Mesh button and selecting the sphere, you will be able to rapidly create all of the ATiles objects corresponding to the sphere's polygons. After they are generated, you have complete control to tweak the objects to match your vision perfectly. To do that, you can also adjust the ATiles ToolBox window size, allowing you to view and modify as many parameters as necessary. In our example, we might alter the material ID variation to utilize a more limited color palette. In this new version 3.0 of the ATiles plugin, we're introducing two more exciting new options. Notice that we now have additional options for the type of object in the parameters rollout. The first is the horizontal cylinder option. This allows you to create a tile-covered cylinder by drawing a baseline and setting a radius where the object size y reflects the length of the cylinder's arc that you want to tile. The second new type is the vertical cylinder, which shares similarities with the previous option. However, in this case, size x represents the cylinder's arc that you want to tile. Achieving these types of objects was challenging with the previous versions. Now they are seamlessly integrated into ATiles plugin, allowing you to cover cylindrical objects with tiles effortlessly. If this video tutorial has provided you with valuable knowledge and you enjoy the content, please consider sharing it and subscribing to our channel. Your support motivates us to keep you updated with new tutorials, product releases, and the latest enhancements for our tools and plugins. We appreciate your engagement. Thank you for watching, and we look forward to bringing you more helpful content.